Hello there. Yeah, good morning, good afternoon, good evening, whatever it is in your time zone for those of you watching this live. A warm welcome to day 2 of the Windows Phone, Building Apps for Windows Phone 8.1 Jumpstart. I'm Andy Wiggly, and I'm a technical evangelist working out of the UK, in case you missed the introductions from yesterday. So just to tell you again, I've been working with mobile for over a decade. I was there in the early days of the Silver Surfer on the WAP thing, and then I've worked with ASP.NET Mobile Controls, Windows Mobile and Windows CE, and obviously more recently Windows Phone, the latest and greatest generation of Microsoft-powered mobile devices. So I've done a few jump starts before, and today's trivial fact about me is, yes, I am a rock star because I not only play rock music, I also like rock climbing. And allegedly, I'm also a character on Game of Thrones, although I'm not sure about that one. With me is Matthias.
Hey, I'm Matthias Shapiro. I am a program manager and technical evangelist at Microsoft. I've been doing Zamel development of all sorts, all flavors, WPF and Silverlight and Windows Phone, pretty much my entire career, which is not really very long. But I was there at the beginning of WPF, learning all that great stuff, and kind of have transitioned from the designer side of things into a more formal developer. All that time I've been a blogger, a demo writer, and just generally a noisemaker. I like to play around with all sorts of different devices and connect them to other devices and make them all do crazy things. So I've been with Windows, doing the Windows Phone stuff since the beginning, and I'm super excited to be a part of the Jumpstart.
Okay, so if you this was the agenda from yesterday. So if you're joining us just joining us now, don't worry about it. This sort of stuff everything obviously is being recorded and will be up on Channel 9 and as a MVA, Microsoft Virtual Academy course. So yesterday we had the introduction and a sort of a mini course. That purple-hued stuff there was all a mini course on building Windows Runtime Zamel apps, which is the new Zamel stack that we've got on Windows Phone 8.1 alongside the Silverlight Zamel stack. So that was what we had, and we wrapped up with a deep dive into data storage and data roaming and sharing contracts, sharing files, file pickers, and open file pickers, which are surprisingly interesting for something. So yeah. I mean, it's good. And then today, we've got loads of really cool stuff for you today. We're going to start with a quick look at background tasks and multitasking. We then got another session on maps and geofencing. Then we're going to look at Azure Mobile Services and networking topics, tiles, notifications, and Action Center. And that will take us up to lunch here on the Pacific Northwest. And then after that break, we'll have a meal break, and then we're going to look at sensors and proximity. So proximity is loads of cool new stuff with NFC and Bluetooth LE. So that's a really nice session. Then we're interacting with user data, contacts and appointments. But actually, the key topic in there is email with attachments. There you go. Yeah. And then we got a detailed session looking at there's loads of cool new stuff with camera and video. So Matthias is going to take us through that. And then Matthias is going to morph into Matthijs, another Matt. We're going to have a guest speaker come in, Matthias Hoekstra, who's going to take us through Enterprise for Windows Phone 8.1. I'm going to give you a quick look through programming SQLite, and then we'll wrap up today's agenda with tooling and diagnostics. We have another half day coming tomorrow, so if you can join us for that as well, that would be cool, where we look at the store, interacting with the store, in-app purchase, submitting your apps, and the whole process you go through for that. Then we'll have a kind of more of a detailed look at building universal apps, one solution, creating apps that will run on Windows Phone and on Windows Tablet PC. Then we're finally, and it's last but definitely not least, we've got a session specifically aimed at our Silverlight app developer community, looking at how you can take full advantage of all the great new features in Windows Phone 8.1. And you can. All these Windows Runtime, all the content we're talking about today, everything is available for both Windows Runtime XAML apps and also Windows Phone Silverlight apps. All right, so let's get started with the first session of today, which is we're going to look at background tasks and multitasking. So in this module, we'll look at what is the multitasking on Windows Phone, how you actually build a background task and what you use to get them to run, which are triggers, the conditions on background task execution, and we've got to look at a little example at the end. So first of all, let's look at the mobile multitasking model. So the first thing, obviously, you have to realize about any mobile device is that resources are constrained. Battery power is the most valuable resource that we have in mobile devices and is the one that has to be protected above all else. What this means is that we have this kind of, all of the mobile OSs are all work the same way, and that any app that is not visible and not being used by any foreground app, not being used by the user at any one time, is suspended. This means it's not using resources, it's not burning battery, it's not running the CPU. This is crucial, obviously, for making sure that that battery goes as long as possible and that the user gets a great user experience and gets the app that they're interacting with at any one time, gets the full resources of the phone, the CPU, and everything. But everything else, they can resume those apps very, very quickly, and it looks to them as if they've been running all the time, but in actual fact, they've been suspended. But of course, when an app is not actually visible, when the user isn't actually interacting, there are lots of ways how it can still interact with the user and give them useful content. One way, obviously, is by updating live tiles or sending toasts. And you can do that both from sort of APIs. You can schedule things to come up when the user is using the foreground app. You can schedule toasts and tile notifications to happen at some point in the future. But the more usual way of doing that is to send notifications through from your back-end system. So you can send push notifications through and use them to update tiles or toasts. But either way, what you're doing is giving that user up-to-date information that's relevant to them. Scheduled toasts, these are the ones that I'm just talking about, where you can set a time schedule where these are going to turn up. And Matthias is going to talk about that in more detail in the very next, session after next. And we have OS broker tasks, which this is the subject of this particular session, where we've got the operating system will run some background code for you under certain conditions, assuming it's got sufficient resources, like its battery isn't dying, and you've programmed for a certain condition to happen. The background tasks and agents is what is the key one around this, which is background execution tasks, which will be executed on certain conditions, like timers or time zone changes or all sorts of kind of conditions. A quick refresh on what we had in Windows Phone 8. So in Windows Phone 8, we had scheduled task, which was two types of scheduled task, a periodic task or a resource-intensive task. And we also had the background transfer service and the background location tracking. Now, periodic task and resource-intensive task, the periodic task, the OS would run that roughly every 30 minutes or so, assuming the battery wasn't into battery saver mode. And you could execute some code for around about 30 seconds or so. Resource-intensive task, you can run for like 10 minutes, but you have to be actually plugged in on charge, and the user isn't actually using that device at that time. So two ways of doing stuff in the background, but perhaps a little bit limiting for some scenarios. So we've got these other ones, the background transfer service for transferring files. We've got a new WinRT API that we will look at in the networking session later this morning. Then we got background location tracking and voice over IP and audio agents running in the background. So let's have a look now at what we've got with Windows Phone 8.1. So first of all, an app can register background tasks. They are actually executed, scheduled and run by the OS. The OS is responsible for running them in its own process. But they are and should always be considered as, they are background extensions of the foreground app. You create them in the same solution. They have access to the same local folders, the app data folders. Same file access, so same storage area, and they're subject to the same permission. So stuff you set in the manifest obviously applies equally to the foreground app as it does to what's happening in the background task. With all of these things, resource usage is constrained by the system. So you haven't got free reign to just run amok and have this crazy background task that's running for tens of minutes and using loads of resources and throwing out push notifications left, right, and center. You're just not going to be allowed to do that. But what you are going to be allowed to do is really valuable work that will allow your app to live on, if you like, when the user isn't actively interacting with it as the foreground app. If the foreground app is running at the same time as its background task, which obviously may or may not happen. But if it is, you can actually communicate between the two. Tasks, the background task can fire progress and completed events, which the foreground app can subscribe to, so it can be notified of the progress of your background task as it's executing. And like we said, we've got the same storage as the foreground app, so they could read and write from the same files, and as a way of communicating between the two of them. And of course, tasks can use Toast, Tiles, and Badge UI, so they can immediately kind of interact with the user by putting out these visible things like Toast put notifications, Tile updates, and Badge updates. And any app can query what task registrations it can have from the system. And the important thing is, obviously, an app here can have more than one different kind of background task. So you can have different ones that are firing for different circumstances. So it's much more flexible than what we had in Windows Phone 8.
One thing I think about the resources that is worth calling out is that a lot of the resource constraints are around CPU seconds instead of being around physical seconds. So if you do need to make an HTTP call, you can do an async, and then while it's making that call and waiting for the server to respond, that's not actually taking up the resources that you're using.
Yeah, so it's an improvement on the old.
It's a massive improvement. It actually gives you a lot more time than you might think.
Yeah. Yeah. So, okay. When you're creating a background task, this is how you add the background task. So I'm going to focus on building out that background work first. You need to add a new project to your solution, and the project type needs to be this Windows Runtime component. So you're just going to add new project and choose the appropriate template, and that will give you the right kind of project that will spit out a DLL which will be executed by the OS at the appropriate time. Once you've created that background task project, you probably want to add a reference to it. You will need to add a reference to that project go into your foreground app project and add reference, and just point at that newly added background task project. Inside the background task, you'll get this. You'll get an empty public class when you create one of those components, and you need to go into that and edit it, so that it inherits from IBackgroundTask. It needs to implement that interface, the IBackgroundTask. IBackgroundTask just has a single method defined in it, which is this run method. So you implement that interface, so you create this run method, and inside there you put your logic. So first of all, if you're doing any async stuff, you first of all need to get a deferral. Then you do all your work. And we don't actually show any work on this particular slide here. And then at the end, you call deferral.complete. You've got this two events that you can handle within the task. First of all, this instance.cancelled event. If you subscribe to that in your background task, while you're running, you might get sort of cancelled in a clean way. Now, it's important that this is why I've called this out. There's an important thing to notice here, that you might get a cancelled notification from the OS if the foreground app has cancelled the background task, or it's a clean cancellation, if you like, which is possible. In which case, you'll get this event fired, and you can kind of do a clean shutdown. But in actual fact, on Windows Phone, if you exceed the memory cap, and I'm going to come on to that at the end of this session, how much memory you've got. You'll just get killed, terminated rudely, as we say. So you should just write your background task expecting that you might be terminated rudely if you get things wrong. So if you code for that, you're going to be in a good place. Then there's also a thing shown on this code is the instance.progress equals, and it's shown as 0 on the code slide here. Just below the blue dash there, instance.progress equals 0. So that's just a progress counter. You just set that property to a 0 right through to 10, and that communicates to the foreground task, and the foreground task can subscribe to the background task's progress reported event, and that will then you can get a kind of a progress count of how far through its work it is, which you could choose to show as a status bar or some kind of information in the foreground app UI if it happens to be running. Okay, so that's how you create the background task. How do you actually schedule these things to run? Well, it's all about this thing called triggers. So triggers are OS things that fire, and there are loads of them. Tasks run in response to a trigger. There's a broad category called system trigger, and the system trigger has loads of different kinds of flavors of it. So the user present, user away is, let me just find the right thing here. The user present, user away is linked with when the screen goes on or off on Windows Phone. The network state change one is fires when the network changes from cell to Wi-Fi or from present to not present. Internet available, well, that's kind of self-explanatory. That fires when the internet it becomes available or goes away. Session connected is fires when the phone boots up. The servicing complete is actually quite an interesting one. So this is when you install an update to your app. So and remember, this happens on Windows Phone 8.1 silently. So the app installation, the app update will get installed. And then at that point, if you've registered for this servicing complete trigger, you can run a background task. So you can do some sort of, upgrade the data, the stored data, if you like. That if your upgrade requires some changes to the state, the persistent data for your app, you can do those changes in the background before the user even runs the app again. So that's an interesting one. Time zone change, of course, when you switch time zone. And then there's a couple there that are noted. Lock screen application added and removed. They're not supported on Windows Phone. They are very important on big Windows. But actually on Windows Phone, background task execution is not linked in any way to this concept of an app being pinned to the lock screen like it is on big Windows. So for Windows Phone, you can just forget all about that. Going down the first one, the next one's in here. The time trigger, obviously, this is one that you just set a time interval and it will run a period. This is the same, actually, as the periodic task we had on Windows Phone 8. Minimum time interval is 30 minutes, but every 30 minutes you can kind of do some work.
Yeah.
Location trigger is all about triggering when a user enters or leaves a geofence location. Matthias is going to show us geofencing in the next session. Maintenance trigger, this is similar to the resource-intensive task for Windows Phone 8. So this is when you're when you're actually on charge and you can do some pretty major work in a background task when the user isn't using it and you're on charge. Push notification trigger is super interesting as well. This is really one of the most exciting new features, I think, in Phone 8.1. You can now send a raw notification from your back-end systems, from the cloud, or from mobile services or whatever, and that can be used to trigger some background execution. So you can run some code when a push notification comes in, something you couldn't do on Windows Phone 8. So this is really cool. And I've actually got a specific example we'll walk through on that towards the end.
Yeah, no, I'm particularly excited about this because maybe if for everyone who doesn't know, a raw notification, most of our notifications have a structure to it. A raw notification is like just a string. You can send just a string as a notification to the system, and the background task will pick it up, and you can kind of do whatever you want at that point.
Yeah.
So,
it's cool stuff. We've also got a bunch of triggers to do with Bluetooth. I'm not going to talk a huge amount about those here because we have a session on Bluetooth and we will come back to those. But essentially when a Bluetooth LE device connects or disconnects, you can run some code. And that really allows you to create really exciting apps that are interacting with Internet of Things kind of stuff. So like I said, we'll come back to that in the Bluetooth LE session later on. You can also put conditions on these. So not only the trigger, but you can also add a condition. So you can say, okay, when this trigger happens, and also the internet is available or not available, or actually background work cost not high. So you can kind of say, well, run this if the system's not kind of busy, which is a nice thing that you can do for your user. So these conditions can be applied as well. And the way you do that is, we'll look at the specific code in a minute, but you use this background task builder is the key object when registering a background task, where you add the trigger and you also can then add this condition. So there's an example at the bottom saying, okay, I want you to run this background task on this trigger and only when the internet is available. So that saves you not trying to do something in a background task where it's clearly going to fail because you need the network or something like that. You need to declare any of these background tasks in the manifest. We've got a single instance shown here where you go into this bit on the left where you have your supported declarations. You add background tasks, and then you have to set for each, and you can add multiple background tasks. So you can have 1, 2, 3, or whatever of these. I don't actually know what the maximum number is, but For each one that you add, you then have to set in the properties what kind of trigger it is. So system event is that broad category with all those subdivisions in it. Then there's other different ones, audio control channel, push notification, location. Control channel is actually not supported on phone. I think that's probably an old image. Then at the entry point, you've got to put the name of the project. My background task is the DLL of this is your background task DLL. And then you need to put the name of the class in the background task. So when you added that Windows Runtime component, it needs to be the name of that project dot the name of the class. And you can add multiple background tasks to this. You don't actually need to specify anything in that executable box. So here's a key thing as well, and this is true, obviously, again, this is all converged, same code on big Windows as it is on Windows Phone. You need to call background execution manager.request access async, and you need to do this on both. But actually what happens on Windows tablet and PC compared to Windows Phone is somewhat different at this point. On Windows, request access async will pop up some UI, a dialog, a confirmation dialog, and this is where the user has to say, okay, I'm cool for this app to be allowed to be pinned to the lock screen. And you have to be pinned to the lock screen to run background tasks on big Windows. On Windows Phone, you still have to call this thing, but it doesn't pop up any UI. There's no user confirmation, but you still need to call it. If you don't call it, your tasks won't run, or they might in certain circumstances run, but with such minimal resources allocated to them that essentially they're going to fail. But you do need to check the status return you get back from that, because if you get background access status .denied, that means there's something stopping your background task from running. And this could be the user has turned off background execution for this app, or the maximum number of background apps across the system has been reached. So you need to put up some UI saying, oh, I want to do this cool stuff for you, but something's stopping me. And the main reason why something may be stopping you is this new app called Battery Saver, where people can see all of the apps on the system that are using their battery and also doing background execution. So this is brand new in Windows Phone 8.1, and they can sort and manage which apps can execute in the background. So they can disallow background execution through here. So this is the full code for registering a background task. You need to create a new background task builder. You give it a name, that's important, and then here's your system trigger. You can specify the different kind of trigger. Obviously, this is a system trigger. A new upper system trigger for the type of system trigger. This is a time zone change example. Then you call task builder.setTrigger. So you set that trigger into that background task builder object. Then you can optionally add a condition. This one is being a condition for internet available. And then, this is very important as well, your background task builder.task entry point, you need to put the name of the class in your background task. And you can just put that in as a string, but by far the best practice is to use the way it's shown here. Type of whatever the my background task dot the task. So IntelliSense will make sure you get that right. Dot full name. So that gives you the full name of that class in your background task project. And then you call task builder dot register. You register your background task. And then optionally at the bottom, this is where you can hook those events that the background task fires. You can hook a progress event to get a progress update or a completed event. You can find out what background task registrations you already have, and then you can unregister them when you're done and re-register them as appropriate. And obviously, you might, if you're unregistered, you want to deregister from any events associated with that as well. The debugger can launch background tasks. So once you've actually got a project like this, you'll find a new thing on the app lifecycle menu there. Under suspend, resume, and suspend and shutdown, you'll see the name of your background task, so you can manually invoke it. All right, let's go and have a look at a quick demo of this. And this is a little solution. Keep it really simple. We've got our foreground app 10, and we've got a background task. The code in the background task. This is it. It's called the project is called My Background Task, and the class is called The Task. And as you see, it implements IBackgroundTask as it has to do. And then inside the run method, well, we get the deferral because we've got an await in the middle of it. So we need to have a deferral on either side. But even if you don't have any await stuff in there, just do it anyway and make it your normal pattern. It doesn't harm to do that, to wrap your execution code in a get deferral, deferral.complete. And then inside the background task, we've got a simple thing. This does a loop. It goes around for 10 times. It updates the progress counter, so it counts up from 0 to 10. And then we actually just simply delay the task we sleep for 2 seconds. So it simulates a long-running task. And then what it does is it writes some information into a file as well, so the foreground app can see it. Now, over in my manifest for the foreground app, we've got the declarations. And here we got, this is where you can select one. I could add another background task, but I don't want to. Oh, rubbish. I removed them both. That's bad.
No, it's still there. Right at the end.
Okay.
The entry point.
Yes.
System event entry point.
Yeah. Okay. There we go.
Yeah.
So so here's the one that we've got. It's a system event because we're going to do a time zone change on it. So this is the one. It's a system event, this is the myBackgroundTask.theTask, which is the entry point into myBackgroundTask. And then in my foreground app, I've got some. So let's run it, and then we'll look at the code in the foreground app. I don't need the. Oops. Don't need the. Not that one. This one. My goodness. Let's get rid of this code. Right. The background task isn't registered at the moment. When I click that button, we're going to go over into the code, and we're going to call the register task. So we're going to call request access async. We're going to new up our background task builder. We're going to create a system trigger of type time zone change, set the trigger, and then register it. So let's go ahead and do that. So there we go. It's now registered. We've got a progress counter, a progress bar here, but the background task isn't running. So if I now go and I'm going to just suspend the foreground app before I do this, just for reasons of this demo. So suspend it. So we're not running our foreground app, but I'm going to go over into the settings, and we're going to change the time zone of this particular phone. Oh, there we go, date and time. So where do you want to go? Hawaii.
Hawaii
nice.
sounds fantastic.
Yeah, let's go to Hawaii here. Okay. Then if we go back and restart our... yeah, I know we're already suspended. Resume our foreground app. The progress bar is halfway across because our background task is running in the background. It's doing that 2 seconds and then sending that progress thing. So it's running in the background. And it's finished, and it's also the foreground app has gone and read that from the file that it ran in to find out when it last ran. Actually, that's it. It's not super exciting, is it really?
I think it's exciting.
Oh, good. I'm glad you do. I'm glad you do. It's just a simple example that illustrates kind of how it works.
Well, I love it because there's so many cool triggers, and they have so many cool conditionals to them that when you combine the types of triggers that you have along with the conditionals, you can do an enormous amount of things with background tasks.
Yeah, it is very powerful. Let me just walk through this one example just to wrap up of how exciting this can be. So if you can imagine, we've got an app, and maybe we're going to use this for the real football, soccer as you guys call it. And maybe you're interested in a football, that's in the way that the rest of the world talks about it, soccer score cloud service, and you're particularly interested, we're going to go through Windows notification services, and we've registered a push background task. So this is the one that fires when a raw notification comes in. You're interested in there's a match going on between Manchester City and Manchester United. So every time there's a goal scored in it, a raw notification is going to get sent through. So after 32 minutes, Yaya Toure has just scored for Manchester City. And a push notification goes through. It's just a raw one. It's XML. It goes through notification services, is intercepted by the background task, so the foreground app isn't even running. And it could pop up a toast to saying, City have scored. But it will store details locally, of course, as well. So whenever the user then goes off into the app, and actually the background task could go back to the cloud service and get more data, so that when the user goes into the app, it's already updated. You've already got that latest information, and they don't have this annoying thing where they sit and watching while the app updates. And then later on, we've got an equalizer by, who should we say, Ryan Giggs. Yeah, I know he's their manager now. Okay, so they've got a goal. So another one goes through, and you can just see how the data keeps getting sent through, and the background task can be storing the updated information. It could be popping up toast, and the user's getting the information that they really like. At the end, it looks like a result for Manchester City there. So well done, the Blues. Yeah, here we go. We could pop up toasts and keep the user informed in various ways. The foreground app can then go into that storage to get all that information that's been gathered and present a full, match report to the user when they later on come along and open up the foreground app. Right, that was the good news. And now the kind of the ugly detail, the resource constraints. So all background tasks have CPU, memory, and network quotas. As Matthias mentioned right earlier, the difference is they're based on actual CPU usage instead of wall clock time. So it was wall clock time on Windows Phone 8, but now we're looking at CPU usage. So you actually get 2 seconds per app of CPU time refreshed every 15 minutes. So every 15 minutes you get a new 2 seconds quota. Doesn't sound like a lot, but actually modern processors and the speed that these things are running at, 2 seconds is not shabby at all. You can do a lot of stuff with that. Then wall clock CPU quota will also be enforced, but you're going to get at least 30 seconds. So the memory quota scales are based on the device capabilities, but the important thing to stress is you need to call request access async to get your full quota. Also, the other thing is on the low spec devices, the 512 meg devices, the number of background apps is limited. So once you get to the bigger devices, that goes away. So again, this is another reason why you need to check the status return for request access async. Memory caps, you also got a memory cap on how much memory you can use. And they're limited by the kind of background task and the amount of physical memory the device has got. So you've got 512 megs on the left there. If you're on a 1 gig device, you get loads more, and 2 gigs, it's pretty, loads of memory actually. So you can see the quotas for the different kinds of tasks there. So just bear that in mind. Keep your processes as lean as possible so they'll run successfully on the widest range of devices. There's a few things that don't run on Windows Phone Store apps. So these are Silverlight only, apps that run under the lock screen. The continuous background location tracking apps are Silverlight 8.0 only. And we'll talk a bit more about that tomorrow. Voice over IP agents, Silverlight only. And we've got this strange foreground agents, which are specific to the wallet, again, are Silverlight only. But that's just, it doesn't mean you can't do them, but you just can't do them in Windows Runtime apps. We've got some other sessions coming up that talk about related topics. But that is me done on background tasks. Okay.
Awesome. Exciting. Yeah. And we'll actually pick that up in the next session where we talk a little bit about background tasks and in the context of geofencing and location.
Okay. We'll see you in a few minutes.
So. Hey, and welcome back. In this session, we're going to cover maps to geolocation and geofencing. We've got a little bit of time and a lot of cool demos, so we're just going to go ahead and get started. So we're going to cover the following 4 topics: launching mapping applications, and so this is going to be launching them from our own application into another application. We're going to be programming the map control, putting elements on the map control and making it look the way we want it to look. Then we're going to look at the location APIs. How do we get the location of our device? How do we track the location of our device, update that location? And then the last one is the very exciting geofencing, where we can use a very lightweight background task sort of geofencing API that is a great way to run location-aware applications in the background without using a sort of really resource-intensive background task that we would have been using in Windows Phone.
It's really
Windows
cool.
Phone 8.
Cool stuff.
Yeah. So start with launching mapping applications. And this is just a mapping URI scheme, and it'll launch to, well, I guess the first version is a mapping URI scheme that launches to Bing Maps. And this can be used as a cross-platform, used on Windows Store, Windows Zamel apps, and it uses all of the same parameters. And it's really, really simple. We just create a new string, and we give that string a URI scheme and some parameters, and then we push it to our launch URI async. So the first URI scheme we can use is this Bing Maps. You can see here. There are a lot of really cool parameters that you can use on this. The CP stands for the center point. Where do we want the application to center around? We can define the zoom level. We can define a bounding box, which is, I believe that's new for 8.1. But it's basically you just give it 4 points, and it does its best to fit the map around for the best view for that sort of box. We can show traffic with the TRFC. We can actually point out a collection of elements, of points by giving it a collection. And then we can do queries and where. The difference between where and the where parameter and the queue parameter is that the where parameter is a search term for a location, and the queue parameter is more of a query term specifically for businesses or locations that have names. Lastly, we can actually go out and tell Bing Maps, hey, I want a route to a point, and it'll start mapping that route to that particular point. We can also do URI schemes that will kick us out to third-party applications. And we can do that using the ms-drive-to and ms-walk-to. This will give us a driving route or a walking route from destination 1 to destination 2, or we can just give it one single destination, and it'll push us out to, it'll go from wherever we happen to be out to that destination. So I want to show a little demo about that. It's pretty fun. And one more. There we go. Okay. So we're going to launch this up on a device. And we've got a couple of hit points, and we'll just walk through those as we show what they do. All right, here's our device. So we can launch the Maps apps, we can launch the driving directions, or we can search for a place. So I'm just going to launch the maps. We've got my center point is, I wonder where that is, and a zoom level of 17. So we hit F5 to run that. You see, that seems to be, that's the Microsoft campus.
Oh, there you go.
So there we are. Right on Microsoft, you can see we've just launched the application, centered it to about where we are. We're actually at a different studio. But we'll go backwards and we'll launch our driving directions here. And you see, this is the MS Drive 2. So this is going to launch that third-party application experience. F5. And you see, this can actually, if you don't like the Here navigation, if you don't like the AT&T navigator, you can download other applications, and other applications, your application, could subscribe to this MS Drive 2 URI scheme. And then you'll actually get a pile of applications that say, hey, I can handle driving directions.
Yeah, the same thing happens on Windows tablets and PCs.
Yep. And this is a cross-platform, sort of thing. So we can do this. Yeah, this is where we actually are, and this is a driving directions to the Microsoft campus. Hey, look at us.
Because we're actually in Redmond Town Center.
Right.
Interested.
A little ways away. Right. But you can see we've got traffic on there, and I think we can actually turn that on or off. So we'll go back to our application. And we can search for a place. It's a little bit early still for me, so I'm going to search for coffee. You see, we're pulling up Bing Maps. We're giving it that center location with a new level and a query with the search term that we've just put in there. So we launch it, and it just gives us a whole bunch of places around here where we can go get sweet coffee. So that's it's actually a really flexible way of integrating maps into your application, and it's really helpful if you don't want to maintain just that full-on mapping experience inside of your application. just kick them out to another mapping application. It's
it's really valuable.
Oh, it's super valuable. Yeah.
You get a load of great functionality for free, effectively.
Yeah. And with the queries, you can really kind of define exactly the sort of views that you want. So the queries and the roots. It's really powerful and it's really easy. So, okay. Now we're going to talk about our runtime maps control.
So this is where you're writing your own mapping. So
right. You say I don't need any help. I can do this all myself.
Or the URI schemes, they don't give you what you need. So.
Right. So there are a lot of map controls across all of the different Windows platforms. If you're working with Silverlight 8.0 or Silverlight 8.1, you're using the what is effectively the here maps control. It's in the namespace Microsoft.phone.maps.controls.map. If you're using Windows Runtime, Phone 8.1, and that's what we'll be showing here, you're using windows.ui.xaml.maps.map control. And then if you're using Windows 8.0, 8.1 store applications, you're using the bing.maps.map. So in the next demo, and I could have shown it in the last one, but in the next one, I'll show a little bit about how we can write an application that hits the phone runtime maps control and the store maps control, and try to see how we can get those to work together.
So there's a few differences, it has to be said. There are differences between working
yes,
with
there
it.
are. Yep.
But with careful design, you can work around these things. And you've got a sample that does that.
Yeah, and we'll show that off. Yeah. So, okay, so what's new and different in Windows Phone 8.1 mapping? As we said, we've got the new the maps control. There is a significant API change. If you have been building mapping applications and geolocation applications in Windows Windows Phone 8.0, there are going to be some substantial updates. But along with those updates, we get cool stuff like we get geofencing. We have a simpler, more consistent geometry. This is actually really exciting. We'll get into this, the map icon, which instead of drawing on top of the map in sort of a heavy Zamel sort of way, we're actually integrating in with the native mapping render control. So it gives us a lot cleaner, a lot faster experience. But we can still do Zamel objects. And we can put them into our map control.children, which makes them bindable. And this is new from Windows Phone 8.0. And that's really valuable. It's nice to have binding back in the applications. Finally, we have improved custom tile source support. So if you don't like any of the tile sources that we provide in the map control, you say, I've got a better tile source for that, you can take that tile source and apply it to map control and effectively create your own map. So all the ways to display your content. There's two big ways to do it. The first one is pins, and the second one is shapes and tiles. The pins category has these Zamel objects that we've attached to the map, and then the map icon objects that are native rendered. Very high performance way of displaying images and text, but not interaction. It's basically just those images and texts. In addition to pins, we've got these shapes and tiles, and the shapes are vector objects that are rendered onto the map. We can render these polylines and polygons. We can render full routes, or the tile source that I mentioned earlier, traffic on top of the maps, and as well as extruded buildings that you see in the right-hand visual there. So, with Zamel children, we've got the Zamel items control is where we're going to shove all of our Zamel children in order to make sure that they show. The way that we get our Zamel children to show up at the right place is a couple of attached properties. The first one is mapControl.location, and then we can give it a geo point. And this just says, I want the object to be right here. And then we can give it a normalized anchor position. Now, the way a normalized anchor position works is it's essentially you view your entire control as a 1x1 grid.
We're talking about the icon.
Right.
So, a 1x1 grid, yeah.
Right, so the icon that you see there, let's say it's a Zamel element. And it's got a vector and it's got some text, and maybe we've bound to that text somehow. We don't want the geolocation to be up at the top left corner, which is where it would be by default. So we can take that normalized anchor position and say, I want it to be x equals 0.5 and y to be 1. And that's going to take that normalized position and say, okay, we're going to move to the middle, we're going to move down to the bottom. That's where I want the geolocation to show up, and then render that Zamel control around that point.
Yeah, so those little icons you have on that picture, they're kind of round circles with a point, and so the point would be, say, hey, that's actually the exact position where it is. So.
Right, by default it would be 0, 0, so it would be kind of the top left corner.
Left, which isn't the right position.
Which isn't where that geolocation is, right, so. We also have, so the map elements. Map elements are drawn by the internal mapping, the native internal mapping system. They're not XAML elements that are laid on top. They're part of the actual map rendering. And that's great, because that means that they're very performant, very clean, and very, very fast. So the three types that we have here are map icons, which contain an image and maybe some text to go along with that image. The map polygons and map polylines. So the map polygons are like the building that you see, the Seattle Art Museum, in that first image. And then the polylines are something like the route that you see in the far right image on the screen. Moving on to tile sources. Tile sources are just tile overlays on the base map.
This has been a big ask, hasn't it, from people?
This has been,
wanted much more flexibility.
There are a lot of developers and a lot of companies that, I mean, geolocation and geomapping is a very big business, and it's very important to make sure that that the people who have their own mapping tiles can take those tiles and pull them into the default map control. That way, they don't have to worry about any of the interaction, any of the user control stuff that goes along with it. They can just provide those mapping tiles that they need. One of the coolest part here is the local map tile data source. This is new for Windows Phone 8.1. I think we've always had a version of the pulling those tile images from the web. But now you can save all that tile source to disk and pull it up locally. So you could save all that mapping information, put on your in your local storage, and just pull it up straight from the disk. Lastly, we have the custom map tile data source, which is a bitmap deferral request. And here is what that means, very, very cleanly. You talk to the map and you say, hey, I want you to give me a bitmap, and I'm going to draw on that bitmap. And the map says, okay, here you go. And then you draw on the bitmap, and then you hand it back to the map, and then the map will render that bitmap that you've drawn onto just straight onto the map. So it's a pretty powerful, pretty customizable way of doing this, of laying these tile sources down on your map. Okay, so now that we have that, let's talk about how we actually do this map rendering. At the very bottom, we give you the opportunity to supply that custom tile source for the background replacement of the map. To use this, you'll need to use a special map setting of none for this feature. On top of that, we hand you the land and water of the map. On top of that, we allow you to put another map layer called background overlay. On top of that is the area information, the parks, industrial areas. Then we give you an area overlay in case there's any area information that you want to add to the map. Then we'll draw the roads. Then you draw your own roads. Then we give. Then the map renders the labels. Then you can add a custom foreground overlay, and then finally on top, we have the map renderer draws all those map icons and the map polygons and the map polylines. The XAML renderer comes along at the very end and draws on top of the actual map rendering the XAML controls and children that you've defined and said that map items control. Okay, so let's look at drawing onto a map. Whee! Okay. Here we are. I'm just going to go ahead and run this application. Oh, I do want to make one note. What we're looking at here is actually a universal application. And so this is something that you'll be able to, I'm going to focus on the Windows Phone version, but we have the demos for this up, and you can go ahead and take a look at how we do this drawing on both the both the Bing maps that we have in Windows and the map control that we have in Windows Phone. Okay, and I'd like to give take this moment to give you see we are in the wonderful area just outside of Amsterdam here.
Amersfoort, yeah.
And I may have to run this again. I don't know. Okay, yeah, I think I'm over here. And this was provided to us by a wonderful MVP known as Hoest van Streek.
Very good.
I think I got it.
Yeah.
And he provided some of the mapping applications, and his work is just fantastic. And so I want to thank a big thanks to Hoest for his work here. So what we've got, we open this up, we've got lines. We're going to show some lines, some polygons, and some points. And we can see how those work with the native map control. We've created our lines. Here we've got some polygons, and if we tap on it, you see we've got some basic interaction there. And then we can add some points. And this, to me, the points one is really exciting if you're showing a lot of data because, I don't know, we got maybe 50 points here, so I think we need some more points. So you can see this is pretty performant. We got a lot of points. We can see more points the more we zoom in, but the real key is we see fewer points the more we zoom out. And so when there are so many points that it would become really a poor user experience, it consolidates those points and decides to show just a few of them. So that's pretty exciting. It's very performant. It's a great way to show a lot of data on your mapping application. So, okay, how do we show all of that data? Let's take a look here. So first we'll start with drawing the lines. And the key part is right here. We're actually going to get lines from a structure that we have called point list. And then to create a polyline, we create some stroke elements, give it a z-index to say what level we want to show it at, and then just give it a path, a geopath, which is a set of basic geopoints. Then we add that data to. I'm sorry. We add that shape. Yeah, we add that shape to our map element, and this is a pattern that you're going to see kind of a lot. In that we do the exact same thing with our map polygons, where we create a map polygon, we create all the stroke elements, we add a fill color as well, and then we give it a geopath, and we add that to our map elements. And that is the same with drawing points, except that we have a couple more parameters here, text and image, and instead of a set of geopoints, we give it a single geopoint. Now, one quick thing that I want to point out here is that our get lines gives back a geopoint, even though what we're using is actually a, let's see here, what we're using is actually the position, which is a basic geolocation. So even we're pulling in a list of geopoints, and those geopoints have basic geolocations. Well, why don't we just pull in a list of geolocations? And the reason for that is because Windows Phone uses geolocation, but Windows uses geopoint. And so this data structure creates a list of geopoints, and now that list of geopoints can be used for Windows Phone or for Windows. But on Windows Phone, we just dig into that geopoint and get the basic geopoint that we're going to end up mapping.
So it's a composite object that you can use for both.
Exactly.
Yeah.
Exactly. And so that's a big question. Why don't you just use a list of basic geopoints? Well, you can, but if you use the geopoint, it contains the geopoint, and now you've got this composite structure that works across both platforms. Okay, so talked about displaying content on the map. We talked about displaying Zamel, data binding small sets of interactive Zamel elements. These are going to be slower to render. They're always going to render. And so if you want something a little bit faster, you can do mapping icons. And then we talked about the tile source, where you can display those tiled images. So how do we get our geolocation? The geolocation API is parity with Windows 8.1. This is something that works well across Windows and Windows Phone. It's the namespace windows.devices.geolocation, and yeah, we can use session types for single position sessions or tracking sessions if we want to track that information. We're actually just going to go over this in the code in just a second, so I'm going to fly through it. We use desired accuracy in meters when we want more granularity than the simple default, which is high. And we can use position source to identify how that position was acquired. So here's the actual code for doing this. And this is code for Windows and Windows Phone. We create our geolocator. We say, I want it to be this accurate. If we didn't set a desired accuracy in meters, then it would, and it's pulling from GPS. GPS can give you a lot of fine-grained control. So it could be firing off a new geoposition for every time you shift your feet, almost. So then we go into this try-catch. Reason we do that is because if we hit this unauthorized access exception, that's basically its way of letting us know that we haven't requested access in the manifest for doing geolocation. And then we get our geoposition async. It's an async call, so we're not holding up the UI while we're trying to get that geolocation. We give it a maximum age, and this basically says if we've gotten our geolocation in the last 5 minutes, maybe we've got a cached geolocation somewhere, then just use that one. And then a timeout in seconds, the time span in seconds says, try to get this geolocation. If you can't get it in 10 seconds, give up. And then we can pull that information out by getting our geolocation coordinate, latitude and longitude. And then we can, it's not in here, but it's in the demo. We can track the location by subscribing to an event that tracks location that fires off every time the geolocation updates. And this, no, it's in here. Okay. And this is the, we get that geolocator, same geolocator we had before, give it a desired accuracy, get a movement threshold, and then subscribe to those events. And make sure that we can unsubscribe to those events later on. Otherwise, we'll keep our page alive, continuously listening to these tracking events. So the mapping services in WinRT, these give us, these are basically services that we provide inside of the application to do some pretty fun, cool stuff. First one is simple driving. And we can just call a service and say, give me a route from position A to position B, and it'll hand back this route object. And we can actually create our own route finder that we can then display our own map using our own route, using our own UI. If you think that's the best UI that you can that is available for driving routes, we can get waypoints and traffic with just a simple get driving traffic from waypoints. And we can actually get a route optimization for time with traffic, so we can avoid that nasty traffic jam by taking the surface streets, perhaps. And then finally, we can get routes for walking directions from one place to another. And this isn't a call. This isn't a task. We're going out to a service to get it. This is all internal to our application. We can also do these queries to find a postal address for a geolocation or geopoint that we already have, or we can try to get a latitude longitude hint for a postal address that we supply. This is not a local places search. You should be sending someone out. If you're going to be doing a serious search, you should be using your own service, or maybe doing a query to Bing Map services. This is just a hint to try to give somebody a single location, because yeah. And so the moment everybody's been waiting for is the geofencing WinRT APIs. Geofencing enables this contextual automatic experience where we can start these actions based on some location notifications. This is great. This allows us to tell the user, hey, you're near this restaurant, or you're near the zoo, or I see you're near work. Did you remember to wear pants or something? These are important things that people want to know, and it's great to have these sorts of reminders attached to our applications.
I've done that.
Right, me too.
Yeah.
It's great to have these sorts of reminders attached to our applications, even when our application's not running in the foreground. And this ties into the background that we did in the previous session, where these geofence notifications, they can be received in the foreground or they can be received in the background. And so now's the moment everybody's been waiting for, which is an architecture diagram.
Yay.
Here's the high-level architecture of how geofencing works. We have our application, we have the location service, and this is a service on our phone. We create a fence, and that registers either a foreground event or a background task notification. And the geolocation takes that and it stores it inside of its geofence storage, and then it uses its geo-tracking service for all applications. It tracks all the geofences at one time. Then when we trigger a geofence for our application, it's going to trigger that task that we've set up that we saw the background task in the previous session. And if the conditions are satisfied, it's going to read that notification detail and run that background task. And we can do something like update our tile or send a toast notification. A geofence has a lot of, this is really exciting to me, it has a lot of really cool, easy to use properties, but you don't need to use any of them. All you need is an ID for your geolocation and a geo shape, which is just a geo position and then a radius around it. Circular geofences are the only ones we support. We don't have geopolylines, but we make up for that with something you're going to see in the next slide. In addition to that, we've got these monitored states. Do we want it to fire when we enter or when we exit or when we take away a geofence? Do we want it to use just one time and then make it go away? How long does the user, the dwell time is how long does the user have to be inside that geofence before we actually shoot off the task? And then we can give a start time or duration to our geofence. We say, this is only during working hours, so I want you to start it at 8 o'clock and make it go for 8 hours or 9 hours, or if you work at Microsoft, 16 hours. The tips and tricks. So this is the recommended radius for a geofence is 50 meters or more. You really don't want to create these little tiny geofences because you're going to be dealing with accuracy issues, and it's just easier on the system and for accuracy's sake to have these relatively larger geofences. And this is the exciting part. This is why we think you'll be okay just using circles. Try to keep it under 1,000 geofences per app.
But if you need to go to 20,000.
Right, if you need to go to 20,000 geofences per app, I guess you can do that. One of the really interesting things about this is with 1,000 geofences per app, you could do something like set up a geofence for every major airport in the United States. And then when someone goes into that airport, you could trigger a background task and load a pile of geofences for the area that you're in. And so you can actually create this a whole system that's dynamically loading new geofences, try to keep it lean, and that gives you a lot of power. It's a really powerful way of monitoring the user's location in a really granular way. So you always want to check the time at which the event occurred, because maybe there was a delay in launching that background task, or the dwell time was a little bit off. And please don't use foreground mode and background mode at the same time. We don't want to fire off 1,000 copies. Well, I guess you probably won't have 1,000 background tasks, but we don't want to fire off 3 copies of the exact same geofence. Okay, now the geofencing demo, the moment everyone's been waiting for. I try to lean up my system here by closing all of my applications while my geofence loads up. Okay. So, okay, we should be good here. Looks like I've got all my breakpoints in place. We're actually going to run this on the emulator and not on the device. And part of the reason is because I'm not going to take a camera and run outside trying to trigger geofences. But the second reason is because we've got this really cool location simulation inside of our emulator, and I think it's great to show that off. So let's first create this route. You see we've got a polyline here, we've got our icons. Let's take a look. So now we're going to set up all of our geofences. And so we're going to set these geofences. This is really simple. We showed a lot of stuff about geofences, but creating a geofence is really this simple. We create a geocircle with a position and our desired a size. And then we don't want it to be a single use. We want it to be persistent. And we want to monitor the entered state and the exit state. We create our geofence using all that information and a dwell time of 1 second. And then we add it to our geofence monitor. So now that you've seen how we do it once, we're not going to follow that through for every single one. And now we're going to look at
and we've drawn circles onto the map here just so you can see where the geofences are.
This is not default. This is not default functionality, but we've done it for the purposes of this demo. And now we can load up a route that we want to go through, and we can load these map points from some pre-recorded data files, and we can actually set all these points up. We could set a route up inside of our emulator and then save those out and then replay that in case we want to take a look at that using using that route in a car at the speed limit, or walking or biking, or just doing it really fast because we have no patience. So once we've got our speed limit and our route, we can hit play, and you now see that we're running along. So this is actually the geolocator. I'm going to go ahead and stop that real fast. I forgot there were. I have a breakpoint around the geolocator, so you can see this is geolocator for both Windows and Windows Phone. Where we create our new geolocator, we got our desired accuracy, our movement threshold, and then we are waiting for that position to change. And when that position changes, we just get to run this position changed event handler. Okay, so get rid of that breakpoint, keep running the application, and we'll try that again. Okay, so it looks like we've hit a geofence. What do we do about it? Well, first we want to read the report from that geofence, and inside that report, we're looking for new state. Have we entered it? Have we exited it? Do one thing if we enter it, another thing if we exit it. In this case, we're going to show some display maneuver. What should we do? This is basically some route guidance that we're going to give alongside our geofence. And so we see as we enter the next geofence, and take a minute here.
So this is putting the route directions out on the bottom of the screen there in that overlay over the map. Now we're entering another geofence.
Yep. And so then
the directions change. Yep. Then we're leaving the geofence, and the car icon comes back again.
Yep.
And that's all driven by the enter and exit on the geofences.
Yep.
So you can make a real nice live display with lots of information happening on it.
Yeah. If you wanted to do something like this, you could run this in a background task, and you could toss up a notification. Let's say you have a geofence and it's gigantic. Let's say it's a kilometer or two around an exit that someone needs to take on a big road trip. You could do something like that, and then it'll just pop up and say, "Hey, your exit's coming up."
It's worth mentioning the location simulation tools in the emulator there. I mean, it's really super cool. I mean, obviously you can go out and write an app or something to record. You can go out in your car and drive around and record the positions. That's one way of doing it.
I've done that.
But actually, that you can actually there's some new ways of just clicking on points on the map, and it will create a sensible route that's linked to sort of road layouts and things for you.
Yep.
So so they've even made it easier to create fake routes and save them out, and then you can just replay them. And actually, it's worth mentioning when working with geofencing, that using routes like this is a way to go, because the geofencing monitoring software inside the OS has got all sorts of optimizations in to kind of eliminate false positives and to kind of throttle the number of change things. So if you kind of start putting loads of push pins all over the map and the positions jumping around in a random sort of a way, it might well reject those readings and say, well, that's not possible. I'm not ignoring that one. So using routes is really the way to go when you're testing this stuff.
Oh, it's extremely powerful, and it's really easy to use. Just open it up and start playing with it. It would be my recommendation. So, okay, so mapping in universal apps. This is a bite the bullet moment. The mapping convergence story is not quite there yet. We're using two different mapping controls.
I like to put it that the phone has converged ahead of Windows 8
right.
at this point. Yeah.
Right. So the Windows has the Bing Maps control. Windows Phone has that Windows Runtime Maps control. Windows is using a location object when it's doing its geolocation grab. Or I'm sorry, when you're putting an item on the map, you're using a location type, and when you're putting an item on the map in Windows Phone, you're using a geopoint type. The events on the map, events happen on the map on the phone and on shapes on Windows 8, and there's a substantial delta between our advanced capabilities and simulations. So, is there any good news in mapping convergence at all? Well, yes, there is. The geolocation API is 100% converged. So in the demos, when we actually are doing that geolocation, we're doing it one time and then sending the information out to the two different applications. Geofencing is 100% converged. You're using the same geofencing types and the same geofencing APIs in Windows Phone as you are in Windows.
And this sample you showed, which we're making available, that's got a Windows 8 head on it as well, hasn't it? Windows 8?
If I had a day or 2 or 3 hours to do this, I'd walk through all of these demos on Windows and Windows Phone because they're all universal demos. They're fantastic.
Yeah, but it's in the sample code.
But it's in the sample code. Download it and go take a look at it. The GeoPoint is also a converged structure, as we saw before, and we can process geodata in a shared part of the PCL. So that is the good news around mapping. And if you're really interested in that, I really recommend go take a look at the demos. So that is a whirlwind tour of geofencing, locations, and mapping controls in Windows and Windows Phone, but mostly Windows Phone. So when we come back, we're going to be covering
Azure Mobile Services, and HTTP client, lots of networking fun stuff, and a little bit about authentication with Web Authentication Broker and stuff. So that's a lot of fun as well. So please join us in a few minutes.